Let us understand the third property. What does third property tells us? Third property tells us that equipotential surfaces are closer to each other where the electric field lines are more crowded. So that means where the electric at the region where the electric field is stronger, at that region the equipotential surfaces are more crowded to each other. Let us understand this. To understand this, we will take another system of charge. Let us take two systems of charges which are having opposite polarities. So, we will have another system of charges of two charges having opposite polarities. Okay. So, we will have positive charge and negative charge. Okay. Now, what will happen if positive charge and negative charge are kept close to each other? The electric field lines. Do you know the property of electric field lines? Electric field lines, they have the tendency to contract, and that's the reason why the opposite charges attract each other. This is the reason why the opposite charges attract each other. So, this will be the electric field lines from positive charge to negative charge. From positive charge to negative charge. From positive charge to negative charge. Okay. And as far as positive charge is concerned, electric field lines always originate from the positive charge. And whereas negative charge is concerned, electric field lines always terminate inside the negative charge. Okay. Now, if you remember the properties of electric field lines, you will come to know that electric field lines are more crowded. Electric field lines are more crowded where the electric field is stronger, or I can say the electric field is stronger where the electric field lines are more crowded. Okay. So, if I am taking this entire region into consideration, okay, this entire region into consideration, in which region is the electric field more stronger? Obviously, the electric field will be more stronger in this region. Why? Because this region have more crowded field lines as compared to this region, right? This region is having more stronger electric field as compared to this region, because this region the electric field lines are more crowded. Okay. So, if this is the case, then how should be the equipotential surfaces? I am first drawing the first surface. Okay. So, this is the first surface. Okay. The second surface would be like this. The third surface would be like this. The fourth surface will be like this, right? Okay. Let us talk about this. This is the first surface. This is the second surface. This is the third surface. Fourth surface. right? And so on. So if you look at here the equipotential surface are more crowded. Even here the equipotential surfaces are more crowded. Over here the equipotential surfaces are less crowded. Here also the equipotential surfaces are less crowded. Why is it so? Because in this region the electric field is stronger, whereas this region the electric field are not so stronger. This region the electric field is stronger because the electric field lines are more congregated, they are more closer to each other. Here in this region the electric field lines are also what? Closer to each other. That's the reason why the equipotential surfaces are also closer to each other. Why is the equipotential surfaces closer to each other? Because of the first property, because of the second property. The second property says that electric field lines should always be normal to the equipotential surfaces. Now, if the electric field lines are congregated over here, if they are crowded over here, then surfaces has to be in such a way that every electric field lines are passing normal to it, and this is the best possible way in which it can be possible. It can happen. That's the reason why the equipotential surfaces are more crowded in this region, and even in this region the electric field the equipotential surfaces are more crowded, right? Have you understood the third property as well? In the same way, you can find out equipotential surfaces for the two charges in having same polarities. Let us find out that. Now we have two charges having same polarity. So, positive charge and another positive charge. How will be the field lines? So, the field lines will look something like this, right? Now, if you look closer, now why are the field lines like this? Because they have the tendency, they exert lateral pressure on each other. That's the reason why the positive charges, the like charges repel from each other, right? Okay. Now, if you look closely, where are the electric field lines more crowded? In this region, the electric field lines are running away from each other. Why? Because they cannot intersect. So, they have to what? Run away from each other. They are exerting lateral pressure on each other, because of which they cannot intersect. So, that means they are running away from each other, because of which this region we have lack of electric field lines. So, here the electric field lines are not crowded. Over here the electric field lines are more crowded. So, what will happen? How will be the equipotential surface? The equipotential surface will be like this, somewhat like this. Here. So, here right? Here the equipotential surfaces are more crowded, and here they are less crowded. Okay. Even here. So, with change in distance, if distance is less, then electric field will be more, right? Okay. In this particular case, the distance is same, okay? from the positive terminal, the distance is what? The same. So that means the potential at every point will be what? The same. So in this case, the electric potential, the equipotential surface will be somewhat like this. So along this surface, at any point, the electric potential will be what? Same. Right? Because we are not changing dr. As the reason the potential remains the same, constant. So this is the surface at this particular point. Right? Okay. So this is how you can understand the properties of equipotential surface, the definition of equipotential surface, and using these cases, you can understand it more thoroughly. Okay. I hope you have understood the session. Thanks a lot.